Week 4, this will be the last question that I look at, and we're looking at what probably is number 17 or some iteration of that for you. All right, we have a Venn diagram below that shows 17 students in Miss Mitchell's class. The diagram shows the members that are part of the tennis club and the soccer club. All right, a student from the class is randomly selected. Let A denote the event the student's in the tennis club. Okay, we'll call this event A. And let B denote the event the student is in the soccer club. The outcomes for the event A are listed in the circle on the left. The outcomes for event B are listed in the circle on the right. Note that Kareem, Kevin, and Raina are outside the circles since they are not members of either tennis or soccer club. Okay, so we know that this entire rectangle or this box here is called a universe. And the universe happens to be the 17 students in Mitchell's class. Now, in Mitchell's class, we have Kira in the middle. Now, she plays both tennis and soccer. And then you have Kareem, Kevin, and Raina, who are in the universe. They're in Mitchell's class, but they are not playing tennis or soccer. All right, let's start with part A. Find the probabilities of the event below. Write each answer as a single fraction. Okay, the probability that you would walk in, let's just say blindfolded, and pick someone out of Mrs. Mitchell's class, and they happen to play tennis. All right, let's highlight that. So we got 1, 2, 3, 4, 5, 6, 7, 8 people out of the whole universe. That'd be 8 chances out of 17 that you would grab somebody that plays tennis. Okay, find the probability that you would grab somebody, let's just say that plays soccer. So we have 1, 2, 3, 4, 5, 6, 7. 7 chances out of 17 humans that you would grab someone that played soccer in Mrs. Mitchell's class. Okay, A and B. Okay, and looks like this in set theory. It looks like a horseshoe. And it's the overlap. Sometimes I think about this as what's in common. So who is the only person in common between tennis and soccer? Well, ding, 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 that's Kira. So Kira is 1 chance that you would grab her out of 17 chances. Okay, we get to the next one. That's a what's called a given probability. If you see that pipe symbol there, right after the B, right, or in between the B and the A, let's see if I can highlight that. That means that you have to be very careful about what's going to be your denominator. So right after the pipe symbol, for me, I always focus on this is the probability that you choose someone in event B, meaning they play soccer, given, right, that they play tennis. Okay, so tennis has to be our denominator. So how many people are in the tennis bubble? 1, 2, 3, 4, 5, 6, 7, 8. So that's our denominator. And out of those 8, right, because that's what we're forced to work with, that's the condition. How many play soccer? Well, that's just Kira. So it's 1 out of 8 chances. Okay, the next one is a straight multiplication. I see they're asking us to multiply 2 probabilities that we already know. Probability of A is 8/17. Probability of B, right, that they play soccer given they play tennis, well, that is 1/8, right? We just figured that out actually. So you could multiply straight across and reduce, or if you remember when you're multiplying fractions, you can reduce on the diagonal. So this would actually be 1/17, which looks, so this is 1/17, which is very much like what we got here. Okay, so maybe we can make a connection here. When you're asked to find the probability of A and B, that's the same as the probability of A times the probability of B given A's occurred. And that may help us out here on our last particular problem, B. So select the probability that is equal to the probability of A and B, which was 1/17. Well, we know it's this guy right here because we just calculated that right here. All right, hope this was helpful to you. I'll see you in the next video.